In this problem, we have a car that has a mass of 1,072 kilos, moving at 6.13 meters per second, and it runs into a brick wall. If the car comes to rest over a period of time that is 12.5 times 10 to the minus 3 seconds, that's 12.5 milliseconds, what is the force of the wall on the car? All right, so we have time. We're asked about force. We know we have momentum when we start, and it goes to zero because the car is coming to a stop when it hits the brick wall. So we're talking about impulse here, right? So, from impulse, the change in momentum equals the force that's applied over some amount of time. What is our change of momentum? Well, our initial momentum is, of course, m1 v1, and our final momentum is 0. So the actual change in momentum is going to be, let me put in my delta p. Our final momentum is 0 minus our initial momentum. All right, so our final momentum is simply minus m1. Well, that's not what I meant to do. Minus m1 v1. Now, the force is opposite to the direction of motion. So the force is going to be negative in this case, right? Because the force of the wall on the car is opposite the direction of motion. And so if we solve force delta t is minus m1 v1, and I forgot the t. And we solve for force, so minus m1 v1 over delta t. And we know delta t because delta t is 12.5 times 10 to minus 3 seconds. We know m1, we know v1. We're ready to calculate. So m1 is 1072 kilos, v1 6.13 meters per second, and delta t is 12.5 times 10 to the minus 3. All right, and you notice how Excel likes to have just a single leading place in front of the decimal place. So it changed my 12.5 times 10 to the minus 3 to 1.25 times 10 to the minus 2. And now we need to calculate the force, which is minus mass times the velocity divided by the time. And so the force is minus 5.26 times 10 to the minus 5th. For Canvas, you're going to need to change this format to number because Canvas doesn't take the exponential notation. And so in Canvas, you're going to put in, this is minus 525,708 newtons. And again, Canvas doesn't take units. All right. So now we know the force on the car. And that's it for this problem.